Alright, boys and girls, welcome to our fourth video lesson, actually our fifth video lesson. It's section 9-4, though, our fourth section in chapter 9. Our study of parametric equations. Okay, parametric equations are just equations still on the xy coordinate plane. That's why we call it a plane curve. It's a plane curve. It's still just on the xy plane, but our x and y are both defined in a third variable. This variable is often called t and is called the parameter. So t is the parameter of our parametric equation, and that's how x and y are defined. If you want to mess around with your graphing calcs and mess around with parametric equations, change the mode to parametric. So go to the mode screen and change our mode from function to parametric. Alrighty? Converting parametric equations to rectangular form. It's actually not that bad. All we do is solve one of our equations for t. If we can do it in terms of x, that's the easiest thing to do. You're then going to substitute that answer for t into our other equation, solve for y, and then we get a function. If it's a trig function, okay, you're going to solve it for theta. Theta is like the t, and we will often use our Pythagorean identities here. All right, let's try one. So we look at this parametric equation right here. We have x is equal to 3 minus 2t. We have y is equal to 2 plus 3t. Before we convert, though, let's just draw a plane curve. Let's draw the graph of this. In order to do that, what we're going to do is we're going to make up some values for t. Typically, we start at t is 0, and we just work our way up. So we have t, we have x, and we have y. So t equals 0, 1, 2, 3. Let's go up to 5. So you guys spend a quick 30 seconds here. Fill out that chart. So plug in t is 0 for both x and y, and let's get our ordered pairs. I'm going to go work on my crossword puzzle right now while you fill in this chart. Stop the tape. You're stopping. I'm working on my crossword. I'll see you in a second. Okay, you should have had fill in the chart so it looks something like this. I guess I stopped at 4, which is fine. But when t is 0, I don't plot that point. T is not anywhere on our graph. There is no t-axis. This is my x-axis. This is my y-axis. There is no t-axis. It's not like an xyz where z comes shooting out, right? Okay, so all I'm going to do now is I'm going to plot the points for x and y. I ignore my t's. So my first ordered pair is 3, 2. So that's about here. My next ordered pair is 1, 5. That's going to be somewhere up here. My next ordered pair is -1, 8, somewhere up here. My next one is -3, 11, up here. And then I have -5, 14, somewhere up there. It looks like I have a line that goes up like that. Okay, and if our parametric equation is only when t is 0 or positive, our point will actually stop here. If I want to have t go into the negative range, then my line will continue extending down. But there is my graph. Oftentimes, our graph is going to stop right here when we get to t equals 0. Okay? Okay, one more thing to talk about is the direction of our graph. Our direction is actually left or negative because our graph moved this way as x got bigger. As t got bigger, x actually went down. As we see here, as t got bigger, x actually went down, right? So our direction is negative or left, or it moves up the line as opposed to going left to right. Let's now actually convert this equation to rectangular form, to xy form. So we're going to what's called eliminate the parameter. I'm going to get rid of my t's. So first thing I'm going to do is I'm going to take my first equation, which is in terms of x, and solve that for t. So I'm going to subtract 3 from both sides. So let's see if I go too fast here for you. -2t is equal to x minus 3. And divide both sides by -2. So now, do you agree? I get t is equal to -1/2 x plus 3/2. I'm now going to take this and plug it in to t right here for y. So I have y is equal to 2 plus 3 times t. Well, t is negative 1/2 x plus 3/2. So in red, our equation is y is equal to negative 3/2 x plus 3 times 3/2 is 9/2 plus 2. 9/2 is 4.5. It looks like I have y equals negative 3/2 x plus 4.5 plus 2 is 6.5. And I think that looks about like my equation that I had before. Okay, so looking at this guy right here, x equals t and y equals t to the third. Let's first of all graph this thing. So we have our t, our x, and our y. If t is 0, 1, 2, 3, and 4, well, x is t. 1, 0, 1, 2, 3, and 4. And as t is 0, y would be 0, 1, 8, 3 to the third, 27. Good thing I can do math. 4 to the third is 64. Okay, so now I'm going to plot these points. I have 0, 0. I'll do it in red. I have 1, 1. Of course, right now I'm ignoring my t's. I'm just looking at my x's and y's. I have 2, 8. I have 3, 27 way up there. I can see I have an x to the third curve. It looks like, again, if t is not going to go into the negative, it's just half of the x to the third curve. But our direction here is right or positive because as t gets bigger, x moves to the right as well. Okay, to simply convert this and put this in rectangular form, I've already solved for t in terms of x. T is equal to x, so I replace this t right here with x. I get y equals x to the third, but just remember now, typically x will not be bigger than 0 because x is only bigger than 0 because t is greater than or equal to 0. Okay, let's look at this guy right here. Let's figure out what this graph looks like. And we'll do that actually just by converting. It's going to be a pain to plot points unless we make up nice numbers for t because we do get square roots. So I'm going to solve this for t in terms of x. So I'm going to take this equation right here. I'm going to square both sides. So t is equal to x squared. Once I have that now, I know that y is equal to 1 minus x squared. But thinking about my parameter here, thinking about t must be a positive number because we're going to take the square root of t, which means now x also must be greater than or equal to 0 because x squared is equal to t. Okay, so now x is greater than 0. I have 1 minus x squared. My graph is going to look like this. It's 1 minus x squared, but it's again just the positive side. And as t gets bigger, x is also going to get bigger, so this is a positive or a right graph. One more here. We have x is equal to cosine and y is equal to 3 sine theta. Okay, this is different because we now have trig. Okay, so in order to do this, I'm going to solve for cosine and for sine. So I already know that cosine theta is equal to x. And down here for sine theta, I'm going to divide both sides by 3. So I'm going to get sine theta is equal to y over 3. And now I'm going to just write my Pythagorean identity. Cos squared plus sine squared is equal to 1. And I'm going to replace now cos squared and sine squared with x squared and y over 3 squared. In other words, if cosine theta is equal to x, that means that cos squared theta is equal to x squared, and sine squared theta is equal to y squared over 9. So cosine squared is x squared plus sine squared is y squared over 9 is equal to 1. If I put x squared over 1, it looks like I have an ellipse. So this parametric equation is an ellipse of x squared plus y squared is equal to 1. That would be a vert ellipse centered at 0, 0. All right, I think that's it, folks. We'll see you soon.